Hello, everybody. So today we're going to finish up Module 13. We're working on Lesson 13.4, Area of Polygons. And so how can you find the area of a polygon? By breaking it into simpler shapes. And so look at the Explore activity, finding areas using tangrams. So a tangram is a square that is divided into smaller shapes. The area of the small square is one square unit. So this shape right here is one square unit. So we're going to use a tangram to find the area of each of the other tangram pieces. So if we place one of the large triangles on top of the other large triangle, what would be true about these triangles? Well, let's look at it this way. So I have one large triangle and I have another large triangle. Okay. So they're saying that what if we place one of the large triangles on top of the other? Well, they're exactly the same, right? So what would be true about that? Well, they'd have to have the same area. So if I can find something that actually writes. Okay, so they are the same, and the areas would be the same. All right. Now, what if we took the square, which we said is one square unit, and we put two small triangles on top of it? We put that one like that, and we put the other one like that. Well, we see that two small triangles equals a square, right? So what's the area of each of the small triangles? Well, it's half of that square, right? So half a square unit. So now arrange the square with one of the triangles, one of the small triangles, so it looks like this. And what would be the area of that combination? So if you have a triangle and half of a small triangle, well, we know this is one square unit, and we know that each of the small triangles is half a square unit. So that has to be 1 1/2 square units. Okay. So each of the small triangles on here is half a square unit. All right. Now, so what is the area of this parallelogram? Well, let's arrange the parallelogram with one of the small triangles. So we have something like that. On top of the square, they would match again, right? So we know that the area of the parallelogram and the square, the parallelogram and the small triangle, is the same as the square and the small triangle. So if that's true, then the parallelogram is one square unit. I put I doubled the yellow, sorry. Parallelogram and the small triangle are equal, so the parallelogram equals the square. All right. So if that's true, then that's one square unit. All right. So complete the rest of the diagram by filling in the remaining areas. Okay. So what would be the area of the medium triangle? So let's put this together with what we have so far. All right. So what is the area of this small triangle? The medium triangle. Well, let's see. Can we use two of the small triangles to equal the area of one of the medium triangles? We can, right? So the area of the medium triangle is also 1. So that helps us figure out the area of everything else. So what's the area of this half of the square? It's 1 plus 1 plus 1. That gives us 3. Plus half and a half is 3 and a half, 4. So if this is 4, this is split in exactly in half. That means that each of the larger triangles is 2. Okay, so now let's use that information to explain how we found that. So 2 of the small triangles equals 1 medium triangle. The area of 1/2 of the square is 4 square units. So the large triangles must be 2 square units each. All right, so again, 2 of the small triangles equal the area of the medium-sized triangle. We took these 2 triangles, and we're able to put them here to match equally. So that means that the area of the medium triangle is 1. We then added that up and came up with a total of 4 square units. And so if this half is 4, then this whole half is 4. And these 2 triangles are equal. So 4 divided by 2 gives us 2 each. All right, so let's keep that idea in mind of using smaller shapes as we work on these. Okay, so you can find the areas of polygons by breaking the polygons into smaller shapes. Then apply the formulas we already know. So for instance, draw a horizontal line segment on the diagram that divides the polygon into a rectangle and a triangle. Okay, so we see the triangle here, and we know the area formula for that, and we know how to find the area of a rectangle. So the rectangle would be base times height, which would be 16 times 7. And that gives us 112 square centimeters. The area of the triangle would be 1/2 the base times the height. And the base of the triangle is 16, take away 8. So this little piece here is 8 centimeters. And the height is 13, take away 7, which is 6. So we have a triangle that's 8 by 6. So half of 8 is 4. 4 times 6 is 24. then we just have to add those together. We have 112 for the rectangle, and we have 24 for the triangle. So 112 plus 24 is 136. So that's all we're really going to be doing. The other method is to think of this as a complete shape. And if it was a complete shape, it would be a 60 by 60, which would be 3,600 square feet. But it's not complete. We have this small missing piece here, which is 40 by 30, because 60 take away 30 is 30, and 60 take away 20 is 40. So 40 times 30 is 1,200. We can take what the area of the whole thing would be, 3,600 square feet, subtract the missing piece, and we'd get 2,400 square feet. What's another way we could solve that? Well, we could break it into two rectangles, right? Okay, so we could use the two rectangles and add the areas of each. So rectangle 1 would be 60 times 20, which equals 1,200. And the area of the second one would be 40. This small piece here is 40 times 30, which is 1,200. 1,200 plus 1,200 equals 2,400 square feet. Okay, so again, all we did was find the area of each of the smaller rectangles and added them together. All right, so 393. So find the area of each of the polygons. So again, it's up to you how you want to solve it. So you could think of this as one full rectangle, or we can break it into two separate rectangles. I'm going to use two separate rectangles. And so the area of the first one is going to be 4 times 8. So 32 meters squared. What's the area of this one? Still going to use the area equals base times height. The base of this one is 6. And its height is this little strip here. Well, if this is 3 and this is 3, that's 3 plus 3 is 6. So 8, take away 6, this piece is 2. So 6 times 2 gives us 12 meters squared. 32 plus 12, 44 square meters. Okay, number 4. Well, there's a couple of ways you could do this. You could think of this as a complete triangle and then subtract the missing, a complete rectangle and subtract the missing triangle. Or we could even think of it as a trapezoid and a rectangle. So I think that's what I'm going to do. I'm going to use a rectangle plus the trapezoid. So the rectangle, base times height. The base is 18, and the height is 18. So we have 18 times 18, which gives us an area of 324 square inches. Now, what's the area of the trapezoid? Well, the trapezoid, 1/2 the height times the sum of base 1 and base 2. What's the height of our trapezoid? Well, these are our two bases. So what's the height? I'm sorry, this is a base and this is a base. So what's this space there? Well, if this whole thing is 36 and this part is 18, then 36 take away 18 is the height. So the height is 18 inches. The sum of base 1, we can call this base 1 18, and base 2 is going to be this piece right here. Well, they're telling us that this section's 9, and the whole line is 18. So 18 take away 9, this piece is 9. So we have half of 18, which is 9 times 27. 27 times 9, 243 inches squared. So let's add those together. 324 plus 243, we get 567 square inches. Okay. All right, the diagram shows the shape. Oh, I'm sorry. Solving real world problems. You can apply the technique of dividing a shape into smaller shapes in problems that involve finding area. So the diagram shows the shape and dimensions of Teresa's rose garden. So we see that one side is 18 feet long and the other one's 24 feet long. But it's not a complete rectangle. We have a small piece that's missing here. Okay, so keep that in mind. So find the area of the smaller top rectangle. So they want us to find this one. So that would be 9 times 15. So the small one is 135 square feet. The large bottom triangle would be 24 times this. Well, that space is 18 take away 9. So 9. 24 times 9 is 216. Add those together, and we get 351 square feet. Same as what we just did, right? So then, knowing the square area or the area of her garden, we can apply that to how much she would need to like cover her garden with different materials. And so in this case, she wants to cover her garden with mulch. And so a bag of mulch covers 12 square feet. So how many bags will she need? Well, we know she needs 351 square feet. You're going to take that 351 and divide by 12. And that gives us 29 and 1/4 bags of mulch. Well, you're not going to buy a fourth bag of mulch. So you just have to add a full bag. So 29 plus 1, 30. Okay, if you only buy 29 bags, you're going to come up short. So we want to go ahead and buy an extra bag. All right, 394. Number 5. So the diagram shows the floor plan of a hotel lobby. The carpet costs $3 per square foot. How much will it cost to carpet the lobby? So we see here we have two trapezoids, right? So couldn't I just find the area of one trapezoid and double it? Yeah, because they're going to have the same area. Okay, I'm going to find the area of the two trapezoids and then multiply by 3. That's going to tell me the cost. So for the trapezoid, we know its area equals half the height times the sum of base 1 and base 2. So what's the height of our shape? So how high is it from this base to this base? Well, they tell us right here, 15.5. So we're going to go half of 15.5 times the sum of 42 plus 30. So we have 1/2 15.5 times 72. Well, I'd rather take half of 72. So I'm going to use the community property of multiplication. And we get 36 times 15.5. All right, so this trapezoid is 558 square feet. Well, so is the other one. So what's the total area? 558 plus 558 gives us 1,116 square feet. And now we need to multiply that by $3. So N equals 1,116 times 3. $3,348. All right, number 1. In the diagram, the area of the large square is 1 square unit. So that means this and this is 1. So the whole thing, each side is 1. The 2 diagonal segments divide the square into 4 equal-sized triangles. 2 of these triangles are divided into smaller red and blue triangles that all have the same height and base length. Find the area of a red triangle. All right, well, so if this whole length of this is 1 unit, these are cutting it in half, right? So that's 1/2. This is 1/2. This base would also be 1/2 because this whole side is 1. So this is half, and that's half. So basically, we have a triangle that's 1/2 the base times the height. Well, the base is 1/2. The height is 1/2. So basically, we have 1/2 times 1/2 times 1/2. Well, 1 times 1 times 1 is 1, and 2 times 2 times 2 is 8. So we have 1/8. 1/8 square unit. And you could make that into a decimal too. So either way. All right, number 2, find the area of each polygon. You could find the area of the whole thing if it was complete and then subtract the missing piece. I'm just going to go ahead and break it like this and go 14 times 4. Okay, so this piece is 14 times 4, which is 56 square feet. And then we have this small piece. This skinnier rectangle. It's not 18. It's 18 take away 4, which is 14, times the height, which would be, the whole thing is 14, but we have to subtract 10 to get this piece, which is 4. So it's the same thing. It's still 14 by 4. So that area is also 56. So 56 plus 56 will give us 112 square feet. All right, number 3. Now this one might be easier to subtract the little missing triangle there. So if it was complete, it would be base times height, 20 times 10, which would be 200 meters squared. And we're going to subtract the area of this small triangle minus the area of the triangle. So the triangle is 1/2 the base times the height. What's the base of our triangle? Well, this piece is 16 up to here. The whole thing was 20. So 20 take away 16 is 4. So we have a base of 4. And we have a height. So this part here is 8. The whole thing would be 10. So 10 take away 8, 2. So we basically have 2 times 2. So the area of this missing piece is 4 meters squared. So 200 take away 4, 196 square meters. All right, number 4. Jess is painting a giant arrow on a playground. Find the area of the giant arrow. If 1 can of paint covers 100 square feet, how many cans should Jess buy? So we have a couple steps here. So first we have to find the area of the paint of the arrow she's going to paint. And then we're going to divide that by 100. All right. So I think I'm going to use a rectangle plus the triangle. So the rectangle is 18 times 10. Well, that's 180 square feet. The triangle, half the base and the height. Well, the base, okay, so this piece is 5, this is 5, and this piece is 10. So we have to add them all together. 5 plus 5 is 10. 10 plus 10 is 20. So we have a base of 20. And what's the height here? Well, from here to the point is 24 feet. The rectangle makes up 18 feet of it. So 24 take away 18 is 6. So 20 times 6. So half of 20 is 10. 10 times 6 is 60 square feet. So we're just going to add those together. 180 plus 60 gives us 240 square feet. How many cans should she buy? Well, that's going to be N equals 240 divided by 100. Well, that's just going to give us 2.4. So if she buys 2 cans, she doesn't have enough. Can't buy 4/10 of a can, so let's make it 3. 3 cans need to be bought. Okay. So number 5, how can you find the area of a polygon that is not one for which you know an area formula? So this one right here. So we had a 1, 2, 3, 4, 5, 6, 7-sided figure. We don't have a formula for that. So what we did was we broke it into 2 smaller shapes that we do know the formula for. Okay, once you've broken them into smaller shapes, just use the formulas for those shapes. All right. Basically, what this is doing is just summarizing what we've been doing. We've been taking larger polygons that we don't know formulas for, breaking them into shapes that we do have formulas for, such as rectangles, triangles, parallelograms, trapezoids, rhombuses, so on. We're going to find the areas of those smaller polygons using a formula, and then add those areas together to get the area of the larger polygon. All right, let's look at 395. Number 6. All right, Alice wants to put wall-to-wall carpeting in a small room with the floor plan shown. Alice says she can find the area of the room by dividing the floor plan into 2 trapezoids. Show how she can divide the floor plan, then find the area using her method. Okay, so we have the dash line here, and we see that we have two trapezoids. Okay. So let's find the area of that. So what's the formula for trapezoid? Half the height times the sum of base 1 and base 2. All right, so let's work on this one first. All right, so we have this base and this base. Okay, so what's the height? What's the space in between those? Well, it's 5 feet, right? So 1/2, 5, times the sum of 7.5 and 15. So we get 2.5 times 22.5. So what's 22.5 times 5? Times 2.5? 22.5 times 2.5. So the area of this trapezoid is 56 1/4 feet squared. Now let's figure out the trapezoid here, the area of that trapezoid. And I'm going to use it over here. Area equals 1/2 height. And what's the height of this trapezoid? Well, these are going to be my bases, so the height is 7.5. The base we're going to use is 5 plus 10. So we have area equals 1/2, 7.5 times 15. Well, I think I'm going to take half of 15, then multiply by 7.5. Half of 15 is 7.5. So we're multiplying 7.5 times 7.5. So that one is also 56 and 25/100. Add them together. (112.5 square feet). Describe another way to find the area. Well, we could subtract the missing piece from a complete rectangle. So 15 times 10 minus, okay, the whole rectangle would be 15 times 10 minus the small piece that's missing, which is 7.5 by 5. So we'd get 150 minus 37.5, which give us 112.5 feet squared. Okay. How much will Alice pay for carpet? That costs $4.50 per square foot. So you're going to take your 112.5 square feet and multiply by 450. So 112.5 times 450. $506.25. All right, 7A. Hal's backyard has a patio, a walkway, and a garden. About what percent of the total area of Hal's backyard is the area taken up by the patio, walkway, and garden? And round to the nearest whole percent. All right, so we got a couple of things we have to do. We have to figure out the area of the patio, the walkway, and the garden, and his entire backyard. Okay, so the whole thing is 17. So 17 by 8. It's 136 square feet. So his whole yard is 136 square feet. What's the patio? The patio is 5 by 8. So the patio is 40 square feet. The walkway is 9 minus 6, so 3, and that's 3 by 8. So the walkway is 24 square feet. And the garden is 6 by 3, so that's 18 square feet. So 136 minus 40 plus 24 plus 18. Actually, we don't need to do that. We just need to find the area, the total area of those three pieces. So 64, 18, 42 plus 40, 82. So 82 square feet out of a total of 136 square feet is taken up by the patio, the walkway, and the garden. So the total is 136. The part that's taken up by the patio, walkway, and garden is 82 square feet. So we just need to divide those and multiply by 100. So 82 divide by 136. All right. So I tried 6, and 6 times 136 was 816. Subtract, we get 4. Let's bring down add another 0. Well, I can't take any from that. So subtract, we get that. And that would be only about 2. All right, so we know that if we multiply this by 100, it would be 60.2. And it said round to the nearest 1%. So 60% of the backyard is taken up by the patio, the walkway, and the garden. All right, B. So one longer side of Hal's backyard lies next to the back of his house. Hal wants to build a fence that costs $9.75 per foot around the other 3 sides. How much will Hal spend on his new fence? So the longer side of his backyard, that's this, right? Okay, so if his house is sitting here, he doesn't need fencing. So he needs fencing here, here, and here. Well, this side is 8. So we know that's 8 plus 17 plus 8. So we get 33 feet. Well, what's 33 times 975? Okay, so cost would be 33 times 975. $321.75. All right, number 8. The students in a furniture making class make a tabletop shaped like the figure shown. The tabletop has squares cut out of the corners. What's the area of the tabletop? Well, I think this one would be easier just to treat it as a complete square, complete rectangle. So if we have this piece is 4, each of those is 2, so we'd have 6. And then this way we'd have 3 plus 1 plus 1, that would be 5. So we'd have an area of 30 minus each of the little areas. Well, that's basically 1 by 1, right? So 1, 2, 3, 4. So 30 minus 4, 26 square feet. Okay, one of the students wants to make a tabletop shaped like a right triangle. This tabletop will have the same area as the tabletop shown. What are a set of possible lengths for the sides that meet in a right angle on this tabletop? So they want something like that, right? So if the area is going to have the same, we know that the area is 26 square feet. We also know that the formula for area of a triangle is 1/2 the base times the height. So if we multiply 26 by 2, that'll tell us what the base and the height have to be. So we need a combination that gives us 52 square inches. All right, so what are some possibilities for 52? Well, 1 times 52, 2 times 26, 3 won't work. 4 times 13, that would work. 6 won't work, 7 won't work, 8, no. So those are really it right there. I guess I'd make it 4 by 13. So I don't know, I guess the length could be 13 and the height could be 4. Okay. Possible lengths are 13 and 4, 2 and 26, and 1 and 52. Those are factors of 52. And when divided by 2, you get 26. Okay, so what we did was we found the possible factors of 52, like 13 and 4. And we know that if we divide that product, we'll get 26. All right, so let's continue with page 396, number 9. So Cho is making banners shaped like triangles out of a rectangular piece of fabric. She cuts 2 triangular banners as shown. What is the area of a triangular banner? So we know that area of triangles is 1/2 the base times the height. The base in this case is 7 inches. And the height is 21 inches. So we have area equals 21 times 3.5. And we get an area of 73.5 square inches. So what are the dimensions of the fabric left over? Well, she's cut off 7 inches right here. So she has 21 inches remaining here. And she still has the height of 21. So she has an area of 21 times 21. So 441 square inches of fabric left. What's the maximum number of banners that Cho can cut out from the fabric? And will she use all the fabric? So she's already cut out 2, right? So how much can she cut out from this piece right here? Well, that would be 441 divided by 73.5. Okay, so 441 divided by 73.5. So let's multiply by 10 to move the decimal point. So let's try 6. Okay, so we get 6. So 6 plus the 2 she already cut out, she can use 8. Cut out 8 banners. And yes, she'll use all the fabric. Okay. Now, the base of a parallelogram is 8 units and the height is 5 units. So the area of the parallelogram is 40 units, right? A segment divides the parallelogram into 2 identical trapezoids. The height of each trapezoid is 5 units. Draw the parallelogram and the 2 trapezoids on the grid shown. Then find the area of one of the trapezoids. Well, we should be able to kind of just use some logic in this case, even without drawing it. If the area of the parallelogram is 40 square units, and you're going to break that parallelogram into 2 identical trapezoids, then the area of each trapezoid has to be 20 square units. Okay, so let's go ahead and draw it. So we know our units has to have a base of 8. So if I break it into this one having a base of 3 and a base of 5, and this side 3 and this side 5, we get a base of 8, and then we have a gap or a height of 5. All right, so what's the area of one of the trapezoids? So 1/2 the height times base 1 plus base 2. And it should come out to 20. So 1/2 times 5 times 3 plus 5. 2.5 times 8. That's going to give us 20 square units. All right, number 11. The figure shown is a square with a triangular hole cut into one side. The ratio of the height of the triangle, to the side length of a square is 7 to 8. Okay, so the side of the triangle square is 8. The height is 7 to 8. So the height is 7. The side of the square is 8. The ratio of the base of the triangle to the side length of the square is 1 to 2. Well, this is a square, right? So if the ratio of this base is 1 to 2, then 2 times what is 8? 4. So the base of the triangle is 4. So the area of the square is 64 inches squared. And we have to subtract the area of this triangle. Triangle is 1/2 the base times the height. The base is 4 and the height is 7. So the area of the triangle, 14 inches squared. 64 minus 14 equals 50 inches squared. Okay. All right, so what did we do? We found the area of the whole square, which would be 8 times 8. We subtracted the area of the triangle. 4 times 7 is 28. Half of that is 14. Subtracted 64 and 14 to get 50. Okay. So that's it for breaking polygons into smaller shapes. So until our next lesson, I will see you soon.